welcome. So in this lecture, we're going to talk about the generalized antiderivative. In the last lecture, we talked about antiderivatives being, if I start with a rate function, I want to get back my original function, right? Then I take the antiderivative. So an antiderivative is a function whose derivative gives me back the original function. And then we noticed, wait one second, if I add a constant and I take the derivative of a constant is 0. So that actually, is the same thing as adding nothing. So now we have a whole bunch of different functions whose derivative would give us the original function. And what we do in this lecture is we kind of group them all together and call them the generalized antiderivative. Okay? So suppose, this is kind of our setup again. So suppose we have that f is a function. So we have f is a function, and we have some antiderivative. So we have that big F, so f is an antiderivative of this function f. Okay? And then here's our new thing, which is that we call, so we're going to call, if I start with that new function, and I just put a plus c next to it, and then I'll say what I really mean by that. So we're going to call f plus c So we're going to call f plus c a generalized antiderivative, or the generalized antiderivative. Okay, so let's kind of think about what's going on with this for a moment. Okay, and we'll do this by looking at a particular example. So let's kind of focus in on an example. So example, we start with f of x equals 3. Remember, this is like our rate of change. This is our derivative. So we want to work backwards. So here we go. So how do we work backwards? What function is going to give us 3? It's going to give you 3x, but we could actually add anything to it. Okay, so f of x equals 3x plus c is the generalized antiderivative. So let's kind of sketch out what we're talking about here. So I just start with my x and y axes. And I can draw just f of x equals 3x is fine, or g of x equals 3x is fine. Okay? But I could also have, so this is like y equals 3x. But I could have others. Let's see. I have a little bit of trouble doing these drawings, but we're going to try. We're going to try really, really hard. Okay. These are supposed to all be parallel. This is the part that I kind of struggle with here. My friend's kid would say to me, next time you should try a little harder if I drew lines like that. Okay, so the idea being maybe this is y equals 3x minus 1, and this would be y equals 3x minus pi. You're going to have to, use your imagination a little bit here. Y equals 3x plus e squared. But the point is, right, what happens when I add a constant to functions like this? What happens is it just shifts the graph vertically, right? And that's precisely, so the generalized antiderivative is something called a family of antiderivatives. So this here, this is a family of functions. It's like a collection of functions where they're all together. So the antiderivative is a family of functions. And then here's kind of another key point about what's going on here in this antiderivative is it's precisely all the vertical translates of a given antiderivative. Okay? And so let me just kind of emphasize that because I think that's kind of a nice point and a nice visualization of what's going on. So note, I was hoping to ignore that I dropped a pen until I realized it was the pen I want. Okay. The antiderivatives are all vertical translations of each other. And what that actually ends up meaning when it comes to lines is that they're parallel. Okay, so again, we peek our head through and talk about kind of our main takeaways of this part. So we started out with, I give you a rate function. I want to know my original function. So I take the antiderivative. I find a function whose derivative will give me the function I want. Okay, and then we say, oh wait, there's actually a whole bunch of these because I can add any constant and it doesn't change the derivative. So we clump all those together in what we call a family of functions, and that is going to be the general antiderivative. It's going to be this family of functions. Now, if you were to graph all them, which you can do, then what you actually get are all the vertical translates of each other, right? So the fact that they precisely differ by a constant graphically is going to mean they're all the vertical translates of each other. So it's this kind of nice picture to have in your mind of what is an antiderivative. It's all these functions that are kind of the vertical translates of each other whose derivative gives you the function that you want. And so that's the antiderivative of the function. And I'll see you in the next lecture.